Trig Identities. In this video we look at how to derive these identities and some simple applications. Example 1, starting with the right angle triangle, you've got the angle, adjacent to the angle, opposite the angle, and the hypotenuse. The sine, cos and tan ratios. Sine theta divided by cos theta, we get these fractions from here. When we divide by a fraction, we multiply by its reciprocal, and the h here and the h here can cancel, leaving us with the opposite over the adjacent, which is tan theta. So sine theta over cos theta is equal to tan theta. We can write this as an equation, but this is true for any value of theta. As long as the value of theta here, here and here is the same, this is always true. So it's also called an identity. Equations are only true for certain values. Identities are true for all values. We can stick to the equal sign for convenience. You must memorize this identity. A quick test on the calculator: sine 20 over cos 20 gives this value, tan 20 gives the same value, so sine over cos is equal to tan. Sine over cos again with the angle as minus 5.2 degrees this time gives this value. Tan for the same angle gives the same value as here, so again sine over cos equals tan. We can rearrange this identity, so if I take the cosine term to the other side, and then if I divide both sides by tan theta, we get this. And these could be useful in problem solving. The identity is true as long as the angle is the same throughout. So the angle here is x plus 20, it's the same throughout. The angle here is 3x, it's the same throughout. Sine over cos equals tan. In this example we have to find the acute angle x. The angle is the same on both sides. We have a sine term, we have a cosine term, so if we divide we could get a tan term. So simple rearrangement, and we know sine over cos is equal to tan here. So tan inverse of 3 over 2, subtract 20. Here is the acute angle we were looking for. I'm going to substitute this back into here and here to see if the equation balances. And I've done that here. So 3 cos x plus 20 is here, where x is 36.3, and we get this value. On the right hand side, 2 sine x plus 20, where x again is this value, gives us this, and it's the same exact value. So the equation balances for this angle. We have to solve this equation. So replacing tan with sine over cos, and then here is the wrong way to proceed. I've now divided both sides by sine x and simplified to get this. Then I've rearranged to make cos x the subject, and this will give some solutions, but there will be missing solutions as well. So what's the right approach? We take this term to the left hand side. There's a sine term here, there's a sine term here. We factorize it out. The whole thing is equal to 0, so either sine x is equal to 0 or this factor here is equal to 0, which gives rise to cos x equals 2/5. And we can see that we have cos x equals 2/5 on both sides, but this is missing on this side, so you would miss solutions here.